Hello guys, welcome back. In today's video, I will show you how to build an object schema validator from scratch. So let's just jump straight into it. The first thing I'll do is to create a new file, boolean.txt, and this file is going to sit inside of a validators folder. Inside of this file, I will create and export a class, boolean validator. Inside this class, I will add a private property, validations, which will be an array of functions. Each function inside of this array will accept a value parameter, which is a boolean, and it is going to return a boolean. Next, I will add an error messages property, which is an array of strings. I will add a constructor function, and inside of that constructor function, I will call this add validation to add a new validation. But we need to define this add validation method, and for that, I will define the add validation method, which will accept two parameters. The first one will be validation, which is a function that accepts a boolean parameter and returns a boolean. The second parameter, error message, will be a string. Inside of this function, we will push the validation parameter inside of the validations array, and I will also push the error message inside of the error messages array. Let's head back to the constructor function. The first argument we pass to the add validation method is a predicate that returns true if the type of the value is a boolean, while the second argument, which is the error message we just read, must be a boolean. Next, I will declare a function true that accepts an optional parameter, error message, which is a string. Inside this function, we will call this the add validation, passing in a predicate that checks if the value is equal to true. Next, we will pass the error message to it if it is defined. Otherwise, we will pass a string must be true. The rule of this method is to ensure that a value which we will pass must be equal to the literal true. Next, we will declare a function false, which accepts an optional parameter, error message, which is a string. The responsibility of this method is to ensure that a value that we will pass must be equal to the literal false. Inside this function, we will call this the add validation, passing in a predicate that checks if the value is equal to false. Next, we will pass the error message to it if it is defined. We will pass a string must be false as the second argument if the error message is not defined. The rule of this method is to ensure that a value which we will pass later must be equal to the literal false. Next, I will add a function validate, which accepts a parameter value whose type is unknown. Inside this function, I will create a variable errors, which is an array of strings, and it will be equal to an empty array initially. I will add a for loop that iterates over these the validations, and for each iteration, we will extract the validation function and the error message. Then I will add a try catch block. Inside the try block, I will check that calling the validation function with the value fails, and if so, I will push the error message into the errors array because we can be sure that there's an error. On the catch block, we will push a string into the errors array that reads validation error with the error. I return an object from this function. This object will have a property is valid, which is a boolean that depends on whether or not the errors array is empty. I will also have a second property, which is the errors array. The rule of this function is to validate a value against all validators registered on an instance of this class, which we will see in action shortly. I will define another function, pass, which accepts a parameter value whose type is unknown. Inside this function, I will validate the method and store the return value in a variable result. If the result dot is valid is false, then I will throw an error joining the errors from the result.errors array with a comma and a space. If everything goes fine, then I will just return the value as a boolean. The rule of this method is to pass a value against all validators registered on an instance of this class. If everything works out, it will get the value back as a boolean. Otherwise, the function will throw an error. I will create a new file, types.ts, and inside this file, I will create an interface, I-based schema, which is generic and accepts a type parameter t. It will have a pass method defined on it which accepts a value whose type is unknown and returns a value whose type will be t. I will define a validate method on this interface which also accepts a value whose type is unknown, and it will return an object with a property property is valid, which is a boolean, and an errors property, which will either be an array or a record with a key whose type is a string, and the type of the value for that key will be an array of strings. Now I will export an abstract class base schema from this file, which is also generic and accepts a type parameter t. This class will implement the iBase schema interface, and as such we have to pass t as a type argument to it and ensure that we have placeholders for the pass and validate functions. I will add a read-only property under underscore type, which will be of type t. The role of this property is just to extract the type t of this object in case we want to use it as a type for a variable in our code. This will come in handy later when we move on into object and array validation. I will head back to the validators /boolean.cs file, where I will import the base schema abstract class and ensure that this boolean validator extends from it. The type argument will be a boolean. Since this is a boolean validator, we also have to call super inside of the constructor function for this class. I will create a new file, schemabuilder.ts, and inside it I will import the boolean validator. I will create and export a variable schema, which will be an object literal. On the object, I will define a boolean method which will be equal to a function that returns an instance of the boolean validator. I will import the schema from the schema builder file and create a variable is valid, which is equal to the result of calling the boolean method on the schema object. I will add a console log statement and chain a call to the true method on the is valid object. We have to pause and head back to the boolean validator to ensure that the true method returns this and the false method also returns this. Let's head back to the index.ts file to check that 1 is less than 2 using the pass method. Running this from the terminal, I can see that it is true. Let's test out the validate method, and you can see that the is valid property is also true. Now let's test out the false method, checking if 1 is greater than 2 while commenting out the first check, and you can see that it returns false. Let's move on from that and let's add number validation, and for that we need to create a new file, number.ts. I will export a class number validator which extends the base schema abstract class while passing in number for the type argument. I will declare a validations property which will be an array of validation functions. Each function will accept an argument value which is a number, and it will return a boolean. I will also declare an error messages array which is an array of strings. I will set it equal to an empty array for now. I will add a constructor function, and inside of it I will call super as required. I will first pause with this constructor function definition to add a new method, add validation, which accepts two parameters, a validation function as the first argument and an error message as the second argument. Inside the function, I will push the validation function inside of the validations array, and I will also push the error message inside of the error messages array. Let's head back to the constructor function, where we will call this.add validation to add a basic number validation that checks the type of the value to be sure that it is a number. We pass a string that reads value must be a number as the second argument if there is an error. I will add a new method min on the number validator. It will accept two parameters. The first will be a value which will be a number, and the second will be an optional error message. Inside the function, we'll call this.add validation, passing in a function that checks if the value being passed or validated is greater than or equal to the value we passed into the function at call time. We also have to pass the error message to it, or a string that reads must be at least value. This ensures that a value being passed is not less than the value will be passed to this function at call time. I will add another method, max, which accepts two parameters. The first will be value, which will be a number, and the second will be an optional error message. Inside the function, I will call this.add validation, passing in a validation function that checks if the value being passed is less than or equal to the value passed in at call time. Then I will pass the error message if it is provided. Else, I will pass a string that reads must be less than value. This ensures that a value being passed is not greater than the value we pass to this function at call time. Next, I will add another method, int, which accepts a single parameter, which is an optional error message. Inside this function, I will call this.add validation, passing in a validation function which ensures that the value being passed is an integer integer using number.isInteger. Next, we pass the optional error message to the add validation function if it is provided. Otherwise, we pass a string must be an integer to the function. We have to ensure that we return this from the main function, the max function, and the int function. This is so that we can use the fluent interface design pattern that allows for method chaining. Next, I will add another function, actual, which checks that a value being passed is equal to an actual value. This function will accept two parameters, value, which is a number, and an optional error message. Inside this function, I will call this.addValidation, passing in a validation function that checks that a value is equal to the value parameter. Next, I will pass in the optional error message or a string that reads value does not match expected. Then I will return this from this function. I will add another function that checks if a value being passed is an even number. This function will accept an optional error message. Inside this function, I will call this.addValidation and pass in a validation function that checks if the remainder of a number divided by 2 is 0. This is the old school way of checking if a number is an even number. Then I will pass in the optional error message if it is provided. Else, I will pass in a string that reads must be even. Then I return this from the function. I will add another function, odd, which checks if a value being passed is an odd number. This function will accept an optional error message parameter. Inside the function, I will call this.addValidation and pass in a validation function that checks if the remainder of a number divided by 2 is 1. Then I will pass in the optional error message if it is provided. Else, I will pass in a string that reads must be odd. Then I will return this from the function. I will head back to the schema builder file where I will add a new property on the schema object, number, which is equal to a function that returns an instance of a number validator. Let's test this out by heading to the index file where I will create a number validator variable which is equal to the result of calling the schema.number function. First of all, let's test out the main validator by chaining a call to the number validator.main with 30 as the minimum value, chaining a call to the pass function with 10 as the value being passed. Let's test this out, and of course it is going to fail, so let's change the value being passed from 10 to 40 and you can see that it is passed successfully. I will change the minimum value to 10 and then I will chain a call to the max function with 50 as the maximum value. You can see that it still works. I will chain another call to the even method after the max method, which still works because obviously 40 is an even number. I will chain a call to the int method, which still works because 40 is an integer. I replace the call to the even method with the call to the odd method and change the value being passed from 40 to 29 and you can see that it still works. I will chain another call to the actual method, setting the actual value to 35 and change the value being passed from 29 to 35, which still works. So let's move on to string validation. I will create a new file, string.ts, inside of the validation folder, and inside of this file I will create and export a class, string validator, which extends from the base schema. I will pass string as a type argument, and inside of this class I will declare a validations property, which is an array of validation functions. Each function will accept a parameter value, which will be a string, and it will return a boolean. This will be an empty array for now. Next, I will add an errors property, which is an array of strings, and it will be an empty array for now. Next, I will add the constructor function, and inside of that constructor function, I will call super. I will pause first to define an add validation function, which accepts two parameters, a validation function as the first argument and an error message as the second argument. Inside the function, I will push the validation function inside of the validations array, and I will also push the error message into the error messages array. I will head back to the constructor function where I will call this.addValidation, passing in a function that checks that the value being passed is a string using the type of operator. Then I will pass in a string that reads value must be a string as the error message. Next, I will add a method mean, which accesses two parameters. The first one, mean length, which will be a number, while the second one will be an optional error message. Inside this function, I will call this.addValidation, passing in a validation function that checks the length of the string being passed is greater than or equal to the min length argument provided at call time. I will pass in the optional error message as a second argument to the addValidation function if it is provided. Otherwise, I will pass in a string that reads the string must be at least min characters. Next, I will return this from this function. I will define a new method max which accepts two parameters. The first one will be max length, which will be a number, while the second one will be an optional error message. Inside this function, I will call this.addValidation, passing in a validation function that checks the length of the string being passed is less than or equal to the max length argument provided at call time. I will pass in the optional error message as a second argument to the addValidation function if it is provided. Otherwise, I will pass in a string that reads the string must be at most max length characters, and then I return this from this function. I will add a function exact which accepts two parameters. The first one, length, will be a number, while the second one will be an optional error message. Inside this function, I will call this.addValidation, passing in a validation function that checks the length of the string being passed is equal to the length argument provided at call time. I will pass in the optional error message as the second argument to the addValidation function if it is provided, or I will pass in a string that reads string must be exactly length characters, and then I will return this from this function. Next, I will add the method regex which accepts two parameters. The first one will be a pattern which is a regular expression, and the second one will be an optional error message which is a string. Inside this function, I will call this.addValidation, passing in a validation function that tests the string being passed against the regular expression parameter. I will pass in the optional error message as the second argument to the addValidation function if it is provided. Otherwise, I will pass in a string. Oops, we have just written the wrong error message here, and my sincere apologies for that. But anyway, I will return this from the function. I will add a function email which accepts an optional error message as the sole parameter. Inside this function, I will return a call from this.regex, passing in a regular expression for email validation as the first argument to the regex function. Next, I will pass in the optional error message if it is provided, or I will pass in a string that reads invalid email format. I will add another method date which accepts an optional error message as a sole parameter. Inside this function, I will return a call from this.regex, passing in a regular expression for date validation as first argument to the regex function. Next, I will pass in the optional error message if it is provided, or I will pass in a string that reads invalid date format. I will add another method UUID which accepts an optional error message as a sole parameter. Inside the function, I will return a call from this.regex, passing in a regular expression for UUID validation as the first argument to the regex function. Next, I will pass in the optional error message parameter if it is provided, or I will pass in a string that reads invalid UUID format. I will add a method phone which accepts an optional error message as the sole parameter. Inside this function, I will return a call from this.regex, passing in a regular expression for phone number validation as the first argument to the regex function. Next, I will pass in the optional error message if it is provided, or I pass in a string that reads invalid phone format. I will add another method URL which accepts an optional error message as the sole argument. Inside this function, I will return a call from this.regex, passing in a regular expression for URL validation as the first argument to the regex function. Next, I will pass in the optional error message if it is provided, or I will pass in a string that reads invalid URL format, and then I will add another method alphanumeric which accepts an optional parameter error message. Inside this function, I will return a call from this.regex, passing in a regular expression for alphanumeric validation as the first argument to the regex function. Next, I will pass in the optional error message if it is provided, or I will pass in a string which reads must only contain letters and number, and then next I will add a function validate which accepts a parameter value whose type is unknown. Inside this function, I will create a variable errors, which is an array of string, and it will be equal to an empty array initially. I will add a for loop that iterates over this stuff validations, and for each iteration we will extract the validation function and the error message. Then I will add a try catch block, and inside the try block I will check that calling the validation function with the value first, and if so I will push the error message into the errors array because we can be sure that there is an error. On the catch block we push a string into the errors array. I will return an object from this function. It have a property is valid, which is a boolean that depends on whether or not the errors array is empty. It will also have a second property, which is the errors array. The role of this function is to validate a value against all string validators registered on this class. I will define another method, pass, which accepts a parameter value whose type is unknown. Inside this function, I will call the validate method and store the return value inside a variable result if the result dot is valid is false. Then I will throw a new error, joining the errors from the result to errors array with a comma and a space. If everything goes fine, I will return the value as a string rather. The role of this method is to pass a value against all string validators registered on this class. If everything works, we get the value back as a string. Otherwise, the function will throw an error. I will head back to the schema builder file where I will add a new property on the schema object string, which is equal to a function that returns an instance of the string validator. Let's test this out by heading to the index file where I will create a string validator variable, which is equal to the result of calling the schema.string function. Inside the console log statement, I will call string validator.main, passing in 3 as an argument to the main function. Then I will chain a call to the pass function to pass a string Sam, which is passed successfully. I will chain a call to the max method, passing in 30 as argument for the maximum character length, which is still passed successfully. I will head back to the string validator class to add one more method, exact, which checks that the string value is exactly equal to a pass value. This method will accept two parameters. The first one will be a string and the second one will be an optional error message. Inside the function, we will call this.addValidation to add a new validation function which checks if the value being passed is equal to the value passed as the argument for the actual value. Next, I will pass in the error message if it is provided, else I will pass a string that reads value must be equal to value. Then I will return this from the function. We have an error because it seems that a method with the name exact already exists, so I rename this method to actual. So let's head back to the index file to test this out, passing in Sam as the argument for the actual method. You can see that it still works and it is passed successfully. I will also chain a call to the alphanumeric method which still works. I replace the actual and alphanumeric method calls with a call to the email method and change the value being passed to sam@gmail.com, which still passes successfully. I replace a call to the email method with a call to the URL method, changing the value being passed from sam@gmail.com to https://sam.com, which still works. Let's move on to array validation, and for that we will create a new file inside of the validators folder named array.ts. Inside this file I will create and export a new class ArrayValidator which accepts a type argument t, which I will set to unknown as default. This class will extend from the base schema. I will pass the type argument t from the class to the base schema. Inside this class I will declare a validations property which is an array of validation functions where each function will accept a value which is an array of t while returning a boolean. This will be set to an empty array for now. Next, I will declare a private error messages property which is an array of strings. I will declare an add validation method which will accept two parameters, a validation function as the first argument and an error message as the second argument. Inside the function, I will push the validation function inside the validations array, and I will also push the error messages into the error messages array. Next, I will add a constructor constructor function, and on it I will first call super, then I will call this dot add validation to add a basic array validation. The array validation function will use array dot is array to check if the value being passed is an array. Then I will pass in an error message that reads value must be an array. Next, I will add a method on the class nin which accepts two parameters. The first one will be the length, which will be a number, while the second one is an optional error message. Inside this method, we will call this to add validation to add a validation function which ensures that the length of the array is greater than or equal to the length parameter. Next, I will pass the error message parameter to the add validation function if it is provided. Otherwise, I will pass in a string that reads must have at least lem elements. We have a bug because val is not recognized as an array, so we have to sort this out in the add validation method by ensuring that each validation function expects an array of t. Then I will return this from the function. I will add a new method max which accepts two parameters. The first one will be the length, which will be a number, while the second one is an optional error message. Inside this method, we will call this to add validation to add a validation function which ensures that the length of the array is lesser than or equal to the length parameter. Next, I will pass the error message parameter to the add validation function if it is provided. Otherwise, I will pass in a string that reads must have at least at most length elements. I will add a new method exact which accepts two parameters. The first one will be length, which will be a number, while the second one is an optional error message. Inside this method, we will call this the add validation to add a validation function which ensures that the length of the array is exactly equal to the length parameter. Next, I will pass the error message parameter to the add validation function if it is provided. Otherwise, I will pass in a string that reads must have exactly length elements. Then I will return this from the function. I will add a new method unique which accepts a single parameter, an optional error message. Inside this method, we will call this the add validation to add a validation function. Inside the validation function, I will create a new set from the value being passed, which is a simple way to create a unique array in JavaScript. Then I will return a predicate that checks if the size of the unique set is equal to the length of the value being passed. Next, I will pass the error message parameter to the add validation function if it is provided. Otherwise, I will pass in a string that reads all elements must be unique. Then I will return this from the function. I will add a new method of which accepts a single parameter, a validator instance that defines what type of elements the array should contain. Inside this method, I will create a new array validator instance with the specific element type u. This new validator copies all existing validations from the current validator like any previously added min or max and checks to maintain the chain. Then I will add a new validation function that iterates through each element in the array being passed and verifies every element passes the provided validator's pass method. Finally, it returns the newly created, fully configured array validator of u instance, which now validates both the array structure and the type of each element. Next, I will add the function validate, which accepts a parameter value whose type is unknown. Inside this function, I will create a variable errors, which is an array of string. It will be equal to an empty array initially. I will add a for loop which iterates over these validations, and for each iteration we will extract the validation function and the error message. Then I will add a try catch block, and inside the try block I will check that calling the validation function with the value phase, and if so, I will push the error message into the errors array because we can be sure that there is an error. On the catch block, I will push a string into the errors array that reads validation error with the error obtained. I will return an object from this function which we have a property is valid, which is a boolean that depends on whether or not the errors array is empty. It will also have a second property which is the errors array. The role of this function is to validate a value against all validators registered on this class. I will add a pass method. The pass method will run the value being passed through all registered validations, throwing an error if any of the validation fails. Next, if an element validator exists from a previous off method call, we will map over the array and pass pass each individual element with that validator, ensuring every element matches the required type. During this mapping, I will catch and rethrow any element passing errors with their array index for clear debugging. Finally, I will return the fully validated array as a type of T. We have to fix a bug by ensuring that the type argument passed to the base schema is of T. So I will head back to the schema builder file where I will add a new property array, which will be equal to a function that accepts a type argument T, which will be unknown by default. This function will accept an optional parameter, element validator, which is a base schema. Then it will return an instance of the array validator strongly typed to T. I will also pass in the element validator to the array validator class. I will head to the index.cs file where I will call schema.array and store the return value in a variable array validator. Let's test out some of the validation methods we have attached to an array, starting with the main method. The argument passed to the main method will be 3. Then I will chain a call to the pass method while passing in an array with 3 items 0, 1, 2, which is passed successfully. I will chain a call to the max item with 6 as the maximum array length. Then I will add 3, 4, 5, which is passed successfully. I will change the max value to 5 while keeping the array the same, and this is expected to throw an error which we get. Next, I will reduce the array to only contain 5 items 0, 1, 2, 3, 4. After the max method, I will chain a call to the exact method, passing 4 as the argument to it. Then I will reduce the array to only contain 3 items to see if this will throw an error, which it does. Then I will increase the array item to contain 4 items, which is passed successfully. Then I will replace the exact method with the unique method, which is also passed successfully. Then I replace 3 with 1 to see if we will get an error, which we get in the console. I replace 1 with 3 and the array is passed successfully. I will chain a call to the off method, passing in a basic number validator, which still works because there are only 3 integers in the array. Then I will chain a call to the min method, passing in 1 as the minimum expected value. Then I will ensure that the array contains 1, 2, 3, 4, and you can see that it is still passing successfully. I will chain a call to the max method, setting 5 as the maximum expected value, which still works. Then I replace 4 with 6, which throws an error, which is expected. I replace 6 with 4, and you can see that everything is working fine. Let's go ahead and move on into ObjectSchemaValidator. I will create a new file, object.ts, and inside of this file, I will create and export a class, ObjectSchemaValidator, which accepts a type parameter T, which will extend the record utility type. It will be a dictionary where each key will be a string and the value of each key will be unknown, which makes sense for now. Then this will be an empty object as default. This class will be a subclass of the base schema while passing in T as the type argument for the base schema. Inside of this class, I will add a shape property, which is an object where the type of each key will be strongly tied to T, that is each key in T. This will be set to an empty object for now. I will add a new method field which will have 2 type parameters, k, which extends from string, and v. This function will also have 2 parameters, name, which is of type k, and a validator. It adds the validator to the internal shape dictionary, associating the name with the validation logic. Then we are going to return the same validator instance but with a TypeScript type that is updated to reflect this new feed. The return type from this function is going to use an intersection T and record of KV. This is us telling TypeScript that the object now includes a new property with its validated type. This allows us to continue type safe chaining, that is to chain multiple calls to the field method. I will add a new static method, create. The static create method will accept a shape object where each property is a validator. I am going to create a fresh empty object schema validator instance and immediately extend it with the provided shape using the extend method. This returns a new validator with its TypeScript generic type automatically inferred to match the structure of the input shape. Each type's property is going to be determined by what the corresponding validator is going to produce using the infer schema helper type, which we are going to define shortly. This provides a declarative Zod-like API for instant object schema creation with full type inference. I will also add a new method extend, which accepts a new shape object containing additional validators. This method will merge merge the new shape with the existing shape stored in the current validator by creating a shallow copy that combines both. It then creates a completely new ObjectSchemaValidator instance. This new ObjectSchemaValidator instance we have created will be fed a TypeScript type that is an intersection of the current validator's type T and a new object type which will be derived from the input shape S, where each property's type is going to be inferred from the corresponding validator attached to it. Finally, I will assign the merge shape to a new instance internal storage, and then I'm going to return this new extended validator. I will add another method, validate. The validate method first checks if the input value is non-null, a non-array object, returning a root error. If not, then I am going to iterate over each field in the internal sheets dictionary, and for each field I will retrieve the corresponding value from the input object and I will run it through the fields validator, ensuring that the validators validates method for structured error collection. Using either the validators validates method for structured error collection or its pass method with a try catch block. If any field validation fail, I will record the error messages under the field's name inside an errors dictionary, and then I will mark overall validation as invalid. Finally, I will return an object containing the overall validation status and the collected field errors. I'm going to define a new method, pass, which calls the validate method to check the objects. If the validation fail, I will format this field error into a readable string, combining field names with their error messages and throwing this as a single error. If validation passes, I will simply return the original value, now type accepted to T, trusting the validators have confirmed its shape. I will add a new method, build, which returns a flattened object schema. I will have to define this flattened utility type, and for that I will head to the types.cs file to add this flattened utility type, flatten, which accepts a type parameter T. This is a TypeScript utility type that takes an intersection type T and converts it into a single flat object type. The empty object and ampersand at the start is the trick that often improves how TypeScript displays or infers the resulting type, making it show as a clean key value pair structure instead of a complex record key value structure intersection. You can see that I already have a type which I have defined here in first schema T. This is a conditional type that extracts the validated data type from the schema instance. This checks if the type T extends base schema infer U, and if it does, it captures and returns the inner type U, like string for string validator. If T is not a schema, it returns never. It is used to get the TypeScript type that a validator would produce from its pass method. Let's head back to the ObjectSchemaValidator to continue with the build method. The build method returns the current validator instance as is, but performs a TypeScript typecast using the flatten utility type to convert the internal intersection type, like record name string and record age number, into a cleaner flat object type with name string age number for better developer experience when viewing the inferred type. I will head to the schema builder file to add an object property. This property will be an object with two methods for creating an object schema. The create method provides a declarative Zod-like API. You pass it a shape object where each property is a validator and returns a fully formed object schema validator with the correct type inferred from the shape. The chain method provides a fluent builder style API. It returns a fresh empty object schema validator instance to which you can dynamically add fields using the field method. This gives the user a choice between two intuitive patterns for defining their object schemas. I will head over to the index file to create an object validator using the object property. I will create a user schema by calling the create method on the object schema. It will have a name property which is the schema.string, an email property which is an email schema. It will have a gender property which is a string with exactly one character. The next one will be an email approved property which is a boolean schema. I will create a new user whose name is Samson. Email is samson@gmail.com. The gender is M and the email approved is false. Then I will use this user schema to pass this new user, which it does successfully and returns the user object for us. Now let's create a book schema. And for us to do that, we are going to use the object schema validator. using the chain method, I will add a field whose key is title and it will be a string validator. I'll add another field whose title is ISBN and it will be an alphanumeric string validator. I'll add another field pages whose type will be a number validator. I'll add another field is published whose type will be a boolean validator. I will chain a call to the build method to flatten and return the schema. If I hover on the book schema, you can see that this type is flattened successfully and we get a clean object. Next, I will create a book type which will be equal to the type of book schema dot underscore type. Hovering on the book type gives us the correct shape of the book type. I will create a new object which is strongly typed to the book type with all of the required feeds. Then I will call book schema dot pass to the new book to validate it, which it does successfully. For nested object types, I will add a new field on the book schema author whose validator will be the user schema validator. Then I will set the author property on the book to be the new user. Let's test an array of book schema by creating an object books which is equal to the result of calling the array functions on the book schema. This returns an array of books. Chain a call to the main method with 1 as the argument to ensure that this array has at least one value. I will try to pass an array with the book object we have created to see if it can be validated against the book's array schema. And you can see that it is validated and passed successfully. That's going to be it for this video, guys. I hope you found it useful and interesting. Absolutely smash the like button if you enjoyed this one. Subscribe to the channel and turn on the bell notification so you can get access to all of our videos as they drop.